Good afternoon, gentlemen. If you're watching this lecture or for the lab, it means that you were unable to be here in person, and so this is our virtual lab. The plan with our virtual labs is that I will record myself completing them. However, I will record the data collection portion. I will have pauses for you to have time to pause the video and record the data that you see. I will not give you any verbal cues onto what that data is, and so you will be recording it all. Then you will submit it online after you finish your lab analysis. All these assignments will be located under Canvas. I have PDF versions uploaded there. You will download that PDF version and then put it up on Notability. It's my understanding you can write on it then. You can complete it on Notability and then turn it in on Canvas. You have until the end of the day. So once the lab is over, then you need to submit everything that you completed. You should be able to complete everything in the lab today and submit it without a problem. However, if you have any tech issues, please email me. And if your Notability is not working, I did install a text box option so you can record the results that you're collecting on a piece of paper and follow along with the lab guide and then submit that on a text box, and that will be as well accepted as well. So you watched the lecture on Thursday, Wednesday this week, so you should have a good understanding on the lab content for you. My goal is I want you to understand how far you can estimate when measuring and how to choose the correct measuring device or instrument. And then I also want to review how to calculate percent error and how to interpret the results of a percent error calculation. So that percent error calculation is what we covered in lecture. It's where our calculated value is subtracted from our actual value, and it's divided by the actual value times 100. I will write it down as we get closer. You will be utilizing that formula in the lab guide, at least on a couple occasions. One inside of the lab, and then our second one will be in the lab analysis. So with your data, you will use some, and then you will be given some numbers to calculate. So it's important that you understand how to use that equation, because if you cannot, please email me. Otherwise, you might get a poor grade on this lab. So my plan is I'll break it up. We're gonna go through experiment 1. We'll do everything together, and then we'll go to experiment 2. We'll do it together, and so on. With experiment 1, we're gonna be measuring volume with graduated cylinders and beakers. So the graduated cylinders we will be using will be a 10 milliliter graduated cylinder. You can tell it's 10 because it ends at 10. A 50 milliliter graduated cylinder. You kind of see that a little better. A 50 milliliter beaker. And a 250 milliliter beaker. To perform this experiment, you need to fill them up with random amounts of water. For simplicity's sake, I went ahead and already did that. And so your responsibility is I will show you as clear as I can the measurements, and you will make your best measurement information, but you do need to include an estimated digit. Now, I know I did not explain estimated digit well in my first lecture, and so I want to kind of step back, and we're going to discuss that before moving on. So estimated digit is your uncertain digit. When you are solving for an estimated digit, you are going to where the smallest decimal place or the smallest number place is. So for example, I have my beaker, and I have my graduated cylinder. My beaker has a lot of lines in between. This middle line represents 25. I cannot clearly tell if this is, where between 200 and 225. And so when I am making my uncertain and estimated digit, I will actually have my estimated digit be my 250 15, where my 15 is my estimate because I'm kind of guessing where it's at. Now, in the case of using a graduated cylinder, such as this one, can you see that? Do you see how they have these individual lines in between? Those mark by 2. So I have 0.2, 0.4, 0.6, 0.8 to get me up to 10. So it's 9, and then it goes 9.2, 9.4, 9.6, 9.8, 10. Because I have those 0.2s, I can estimate my decimal, and additionally can understand, like, here is 9.4 or 9.5. I can give an additional decimal place as my estimated value because I have an idea on where those values lie. And so when you are making your estimate with your graduated cylinders, you can go at least 0.1 decimal places. So I can do a 0.2, a 0.6, a 0.9. If I believe it is exactly on like where 20 would be, it would be a 0.0. No matter what, you can at least have 1 decimal place when measuring with your graduated cylinders. Excuse me. With my beakers, however, especially these ones, on my 50, these are increments of 10, so I can make an estimate on where between it lands. However, I cannot make a decimal place. So I can do like a 15, a 14, a 13, where my 5, my 4, and my 3 are considered my estimated digit. And like we discussed with this is my, with 25 in between, and so I will have my estimated digit be like my 224 or 210, where the 10 and the 4 and all of that are my estimated numbers because I cannot give a clear enough estimate past that. So moving on, I'll try and make this, excuse me. I want you to record the volume of my graduated cylinder. This would be eye level for you. If you were in the lab, I would request that you did actually move to an eye level. However, this is the best we can get. And remember, when you're taking the mass of a graduated cylinder, you are always going to take the meniscus where it dips, and that is how you record the mass. So please record this mass on your handout. The next measurement you will be taking is your 50 milliliter graduated cylinder. Again, you can at least go 0.1 decimal places, and this is at eye level. Make sure you are recording the mass with the meniscus. Now we are moving into our 50 milliliter beaker. Let me, when you are measuring this, you will get as eye level, as you can get. Here is eye level for this beaker. Record the volume on your handout. And finally, we're gonna do it again. Here is the eye level for the level, the 250 milliliter beaker. Record this volume under your handout. You will then answer step 2. However, you will answer that after you complete collecting the data, because you can go back and answer that question because it's more of an understanding. On experiment 2, we are now going to be measuring the temperature with a thermometer. The thermometers here are always measured in degrees Celsius when you are in the lab here. When you measure with a thermometer, never measure it like this and don't have it touching the glass. Always measure it where it's up here and kind of off the glass. Again, you want to get down to eye level when measuring this, and also when you measure it, you can go at least 0.1 decimal places. Here is the temperature. Let me see if I can, there we go. Record this in your lab handout, pause it if you need additional time. Step 2 is where you use our percent value equation, percent error, excuse me. That is found, percent error is found where you do the calculated value minus the actual value all over the actual value times 100. Here it is. In this case, your calculated value would be the temperature that you just found on the thermometer, and your actual will be the 25 degrees Celsius that I gave you in step 2. You'll complete this by showing all of your work and using an approved calculator. Moving on, we are going to do experiment 3, measuring objects' length. We're going to measure a nail, and we are actually, instead of a straw, going to be measuring a colored pencil, and then the length of our lab station and the width of our lab station. I will give you the length of our lab station and the width of our lab station. However, you will be showing me your understanding of measuring with a nail and a colored pencil. So, let's do that. With measuring the nail, we always want to measure in centimeters. So here is my centimeter side. Here is my nail. Because you have centimeters, you can round at least 0.1 decimal places. So take your measurement now. Okay. Now we'll be measuring a colored pencil. However, I will have to zoom out, so please be patient as I set this up. Please take the measurement of your colored pencil. The length of our lab station and the width of our lab station are listed here. I found it by using a meter stick as well as my smaller ruler, and I made sure that I was measuring in centimeters. Here is the length, here is the width. When you have this information down, record it, and then you will use this information here to find the area. The next thing that we're going to do is experiment 4, measuring mass with a balance. First, we need to find the mass of our 100 milliliter graduated cylinder. When I find the mass, I use what I call a mass balance. I have to ensure that it is in the unit grams, and then I can proceed. I'm gonna flip it. Here is my 100 milliliter graduated cylinder. I am measuring it empty first. Here is the mass for the graduated cylinder, empty. I will now fill it with a random amount of water. I'm skipping ahead right now to number 3, and then we will come back to number 2. However, we are now going to place our graduated cylinder with the water on the balance and record the mass. Here is the mass for the graduated cylinder with the addition of the water. Remember, it is in grams, and make sure to record this down. Oh goodness. Now record the mass of the graduated cylinder at eye level. Now going to record the mass of our graduated cylinder at eye level. You will then answer questions 4 through 6 on your own. And then all I have left is the lab analysis questions for you. If you have any questions, please let me know. I know some of those readings are a little difficult, especially being online. However, complete them to the best of your ability. That's all I ask. So make sure that you have this submitted by the end of today, and that is all that I ask for you to do. Have a wonderful day, and again, if you're having any issues, let me know and email me. Bye.